Everybody, now we are going to start analysis of frames using Castigliano's second theorem. In this case, we are going to study portal frames and their shear force bending moment diagram. Majorly in these portal frames, we are going to just go through the bending moment diagrams. Now, we know the idea about the Castigliano's second theorem of beams. In that case, we have just understand that whenever we have redundant, at that point deflection is zero. On the basis of that consideration, we are going to analyze the frame. So, for the understanding of this frames analysis using Castigliano's second theorem, here I have taken three case of the frame. First one is find the reaction at B for a frame shown in the figure and draw bending moment diagram for that. This is our frame. Point load 20 kN acting at D, roller support at B and fixed support at C. Joint C is always a rigid joint. So, here whenever we are going to finding out the SI of this frame, that is 3 reaction over here, 1 reaction over here. So, 4 minus 3 conditions, that is 1. So, we are going to take horizontal force at B, HB as a redundant. So, our frame will become a cantilever frame. Now, SI is 1 and HB as a redundant. So, the segments are BC, CB and BA. Origin BC and B, limit all 0 to 2. Now MX, for the first case DC, from D to C we are going to take assume X, so it is minus 20 into X. C to B, it is minus 20 into 4 as we know, and B to A minus 40 plus R into X. It is a redundant. That's why here we are going to take redundant as R. Now del mx upon del R, that is 0 because there is no R over here. Here also 0, no R over here, and here that is X. So our consideration that the deflection at support, that is 0. So 1 upon EI integration 0 to L mx del mx upon del R dx is equal to 0. Now what we have to going to do, we have to multiply these two. That's why 1 upon EI integration 0 to 2 minus 20 into x into 0. 1 upon EI 0 to 2 minus 40 into x, 40 into 0 plus 1 upon EI minus 40 plus R into x dx. So this 2 is 0, only we have this one. So the integration of this minus 40 x square by 2 plus R into x cube by 3, limit 0 to 2. This is the simple integration process, and that you know. So what is done over there? 80 plus 2.67 R is equal to 0. That's why the reaction at B we will get, that is 30. Now bending moment calculation. At free end moment is 0, that we know. At C point it is minus 40. At B point again it is minus 40, and at A, that is minus 40 plus R into X, means it is 30 into 2, right? So it is 20. Now from the basis of this moment, we have to plot the bending moment diagram, and that is at D is 0, here minus 40, so here we are going to take minus 40, at B again minus 40, and A, that is plus 20, so it is over here. Now we are going to plot this bending moment diagram and connected by the simple line and inclined line, because all the forces are point loads, so there is no curve in this diagram. Clear? Now in next case, we are going to take a portal frame with 2 columns, and in this case what we are going to do, a portal frame capital A, B, C, D is hinged at A and D and has rigid at B and C as shown in the figure. Here these two support is hinge and B and C are rigid support. Using the method of minimum strain energy, means it is a Castigliano's second theorem. Analyze the frame and draw bending moment diagram. For this case, we have to draw bending moment diagram. So here we have two reaction, that is HA and VA, and here two reaction, that is VB and HD. B and C joints are rigid joint. Point load 6 kN acting at the 1 meter from B to C. So what we are going to do, here we have SI, that is 2 over here, 2 over here, means 4 minus 1. So we have to take 1 redundant, and we are going to take HD as a redundant, that is simply H. Now here that no horizontal force, that's why HA and HD both are same, means it is H over here, then here also it is H. Clear? Now SI is equal to 4 minus 3 is equal to 1. Take HD as a redundant, that's why HD is equal to H. Now we know that sigma H is equal to 0, that's why HA is equal to HD, and that is H. Got it? Now reactions. So for the finding out VA and VB, we know all the process in previous subjects. SA1 we have solved number of frames, so from that we can calculate this two reactions, that is taking moment at A, VD into 3 is equal to 6 into 1, that's why VD is equal to 2 kilonewton and VA is equal to 4 kilonewton. From the basis of these two reactions and horizontal redundant, that is H, we are going to make the table for the segment origin limit mx and del mx upon del h, because here h is the redundant. We can take notation as r also, we can take any, even we can take hd as a redundant, so here we can take hd also. We have a number of choice, we can utilize any notation, but the methodology doesn't change. So here AB, BE, DC and CE, left to right and right to left, both consideration will be taken over here. Now origin A, B, D and C. Limit 0 to 3, 0 to 1, 0 to 3 and 0 to 2. First from A we have to take x distance from A to B and the moment that is minus h into x, so it is minus x. 4 into x plus 3 into h means it is 3 minus h into x, that is minus x over here, 2x minus 3h, so minus 3 over here. Now we know that the horizontal deflection at the support, that is 0, so our equation, that is 1 upon Ei 0 to L mx del mx upon del h into dx. Now 1 upon Ei is equal to integration 0 to 3 for the first one, hx square dx, for the second one 4x minus 3h into minus 3, for third one minus h into x into minus x, so hx square, and this is the final one. Now integration of this, that is hx cube by 3, 0 to 3 minus 12 into x square by 2 plus 9hx 0 to 1 plus hx cube by 3, 0 to 3 plus in the bracket minus 6 x square by 2 plus 9xh integration 0 to 2 is equal to 0. Now solution of this, put the value of x from this and we will get 9h plus in the bracket minus 6 plus 9h plus 9h minus 12 plus 18h is equal to 0. So 45h is equal to 18. So h is equal to 0.4 kilonewton that we will get from the analysis. Now from the basis of this redundant, means it is h, we can calculate the moment at each point. Moment at A is 0, moment at B minus 3 into h is minus 12, moment at C again minus 3 into h, and moment at D 0, and moment at E, that is 2.8. Clear everybody? Now here both minus, so we can take minus over here. At C it is also minus, A and B is 0, and here minus 2.8. So this is our diagram, and just connect this line with the help of point load. So it is inclined line. Now this is simple, only vertical point load there. Now what happens when the horizontal point load is applied in the frame, right? It is little bit difficult, and the analysis for this kind of cases is the sway type of frame, and that sway type of frame is just analyzed by us in our previous two methods. Now here it is a horizontal force, so it can be sway, but how it is calculation using Castigliano's second theorem, that is important for us. So what is here? Analyze the portal frame shown in the figure using Castigliano's second theorem. Ei is constant for us. Here A to B, support A is fixed. Here B, point load is there. It is 4 meter, 4 meter and 4 meter. Support D is hinge support, right? This is our frame. What we have to do, as we know, whenever we have this kind of case, first we have to consideration that how many redundants are there. So here SI is equal to 3 over here and 2 over here, so it is 5 minus 3, So 2 redundant we have to take, and the redundants are for this frame, that is horizontal force HA, here MA, these two as a redundant. So we have to take HA is equal to H, HA is equal to H, right? Now what happened? These two as a redundant. Now for the whole frame, sigma H is equal to 0, this HA plus HD is equal to 10. So HA is equal to H, we will get HD is equal to 10 minus H, which is over here. Now these two reactions must be calculated by us, and that we know sigma V is equal to 0 and moment over there is 0. Now these two reactions must be calculated by us. VA is vertical 10 minus m by 4 and VA is downward 10 minus m by 4. Both are same. This reaction is used for the taking mx for our each segment. Now how it is calculated, just see over here. This we know HD is equal to 10 minus H. Now taking moment at A, sigma MA is equal to 0. Now VD into 4 plus M, that is our moment, is equal to 10 into 4. Now VD is equal to 10 minus M by 4. This is plus, means it is upward, and VA is equal to 10 minus M by 4, which is downward. Now the table, that is segment, origin, limit, mx, del mx upon del h, and another one, that is del mx upon del m. What is done over here? That is AB, origin A, limit 0 to 4. Here anticlockwise moment that we have taken, that is minus m plus h into x. So here it is x and this is minus 1. D to C, that is D 0 to 4, in the bracket minus 10 into h into x, and there is no moment, so it is 0. Now C to B, the origin is C. So what happened? 0 to 4 minus 10 into, so 10 minus h into 4 plus 10 minus m by 4 into x, so it is 4 and it is 1 upon 4, and we multiply with x, so we can take it is x by 4. Now from the basis of these two, we know that the horizontal reaction is 0, that's why multiplication of these two and integrate that, that is 0. And number 2, mx into del mx upon del m, these two, right? So we can consider that the moment is, or rotation is 0 over there, because at fixed support rotation is 0, that we know that. Now delta h is equal to 0, and we have this equation, that is 1 upon Ei integration 0 to L mx del mx upon del h into dx is equal to 0. Now put these all values. So what happened? Integration 0 to L minus m plus hx into x dx plus integration 0 to 4 minus, in the bracket 10 minus h into x dx plus integration 0 to 4 in the bracket minus 10 minus h into 4 plus 10 minus, this is our reaction, into x into 4, that is 0. Now integration of this, we know that minus mx square by 2 plus hx cube by 3, limit 0 to 4, plus minus 10 x cube upon 3 plus h x cube by 3, 0 to 4, and the multiplication of this all is minus 160 x plus 16 hx plus 40x square by 2 minus mx square by 2, 0 to 4. Now put the value of x in this equation, so we will get minus 8m plus 21.33h minus 213.33 plus 21.33h minus 640 plus 64h plus 320 minus 8m is equal to 0. So we will get one equation that is in the form of h and m, because here we have two unknown. So we have two equation for the solution of that. Now we know that rotation at a, that is 0. So what we will get, multiplication of this mx into del mx upon del m integration with respect to L, 0 to L, that is 0. Now integration of 0 to, put all the value, minus m plus hx into dx integration 0 to L minus 10 x into 0 plus integration 0 to 4 10 minus h into x, right? This is equal to 0. Just multiplication of our mx with del mx upon del m. So after integrating that, what we will get, this one equation, and that is minus 16h plus 5.33 m is equal to minus 26.67. Now solving these two, we will get h and m. H is equal to 7.73 kilonewton, it is plus, means it is left side, and moment, that is 80.20, that is plus, means it is anti-clockwise. Now from that we can get HD, that is 2.27 kilonewton, VA, that is 5.45 kilonewton, MB, that is plus 12.72 kilonewton into meter. At C moment we will get minus 9.8. So from this we can put moment at A, that is anti-clockwise 18.20, at B plus, means it is inside, at C it is minus, means outside, and just draw this bending moment and connect this line, which will give us the bending moment diagram of the frame with horizontal load for the Castigliano's second theorem. Right? Now here all kind of examples are solved by us. Now in next lecture we are going to start our new chapter, that is influence line. It is most important for the analysis of bridge. So let's meet in next lecture. Thank you very much.